Okay, so before I start the presentation, a bit of an introduction about the company that I work for. So I work for a company called the Recyclusgroup. And the Recyclusgroup owns 3 different companies. One is called Lye Battery Recycling, where I'm based. So this focuses on recycling of lithium-ion batteries. One is called Halo. That focuses on lead-acid battery recycling. And one is called Lye Box. And this is where we make storage boxes, transport ADR compliant transport boxes. They're compliant to ADR 911, which means that they can transport critical batteries. Okay, so let's get on to the presentation. So when we talk about lithium-ion battery recycling or recycling in general, there's always a number of different steps that it has to go through. So initially, in this case, the batteries. So they are in their use phase. So in this case, a Tesla Cybertruck. And then when it comes to the end of life, the battery is taken out, it's decommissioned, it's shredded, and the materials are sorted. Then the black mass that's produced from those batteries is then sent to a hydrometallurgical refiner, who then separate out the different metals, so things like nickel, cobalt, manganese, lithium, and then use them to remanufacture the cathode material, the active components that make the battery work, and then that's used to manufacture new batteries, and so the cycle goes on. Now today I'm only going to be focusing on this part, the decommissioning, shredding and sorting. And the reason for that is because most of my experience is in this part, but also because it's probably the most hazardous part of the process, or the most dangerous part of the process. Now, I'm only going to limit it to portable batteries, so I'm not going to talk about EV batteries, mainly because portable batteries are a lot more exciting. They're a lot more hazardous, a lot more dangerous, as you'll find out. Okay, so the shredding and sorting process in general goes like this. This is just a general one, so they can be arranged differently, but generally it will contain these sorts of things. So initially, you have some sort of a pre-acceptance. So the pre-acceptance is that before you get the batteries or before you buy the batteries, you have to communicate with the customer to ensure that the batteries that you get are exactly what you want. So as you'll see in the next few slides, a lot of the times people will send you batteries that are not lithium-ion batteries, and that in itself is a major hazard. Okay, then when the batteries come to your plant, you have to then accept them somehow, and you have to sort them into different chemistries, different battery types, etc. The batteries that are that fail that are singled out in that sorting process. So for example, if they're not lithium-ion batteries, or if they're about to go and be on fire, they're then put into a quarantine area. The batteries that are lithium-ion batteries and are good batteries, you put them into storage. And then once you're ready to shred them, or once you're ready to process them, they're then taken to the shredding. After the shredding, they're then conveyed to a dryer, or conveyance equipment. And then after the electrolyte is dried off, it's then sieved. So it's the initial sieving where you sieve out the black mass, or screen out the black mass. Then after that, you do a magnetic separation, so you get the steel, and then some sort of a density separation. So you take out some of the heavy components. Then an eddy current separation, so you take out the copper and aluminium, the heavy bits anyway. Then you put into another sort of a milling stage. So the copper and aluminium foils will still have quite a bit of black mass or cathode coating on them. So you do another milling step to remove that coating, and then you do another sieving step to get the black mass. Then you can do another density separation, so things like a zigzag separator where you get the polymers and copper and aluminium separated. Then you can collect your black mass and store it. So that's essentially the process in a nutshell. And each one of these stages, they will have their own health and safety issues, and I'll go through that and talk about that. Okay, so in the pre-acceptance, so this is before the batteries even arrive, you have to make sure that the correct batteries are sent to you. Now, you have to develop a method to do that, and that takes time. So it took us about a year to get everything right in this case. So the pre-acceptance form you send it to the customer fills it in. They have to have the right waste codes. They have to have pictures of everything that they're sending you. And generally speaking, there's three types of customers that will be sending you batteries. So the first one is a producer of batteries. Now, these are either manufacturing facilities or they're recyclers. So they take the batteries out and then they send it to you. Now, these generally send you really good batteries. So the batteries that you want would come from people like these or companies like these. The next one is compliance schemes. So compliance schemes are companies that recycle batteries on behalf of producers. People like, for example, Duracell, they would pay a compliance scheme to recycle their batteries. Now these batteries are generally good as well. So the compliance scheme sorts the batteries and then they send it to you. Now, by the way, this is in the UK. I don't know what other countries do, but in the UK it works like this. Okay, then finally you then have other recyclers. So these are the ones that you have to watch out for the most. So other recyclers, they could send you mixed batteries, they can send you damaged batteries generally. So they have a recycling process which the batteries go through. And some of them get damaged and then they put them into containers, etc., and then they send them to you. So do not assume that you will only be sent lithium-ion batteries. So some batteries, they cost far more to recycle than lithium-ion batteries. So a cheap option is to just throw them in with lithium-ion batteries, mix them in, and then send them to a lithium-ion battery recycler. And of course, the best way to get around this is to have very heavy penalties for unexpected waste. Unexpected waste could be anything that is not a lithium-ion battery, or it could be a lithium-ion battery that's not in a condition that the customer said it was in. So once you've done the pre-acceptance form, so you know what you're getting, then the material then comes to your yard. So you have to then accept the material and you have to sort it. Now, every pallet must be checked and its contents have to be scrutinized. And the easiest way to do this is to tip it out onto some sort of a table and then sort it out, because you'll find that at least 20% of the batteries will be non-lithium-ion batteries. This is from recyclers, other recyclers. Now, as soon as the transportation arrives on site, that's when you have to be very careful. So a few weeks ago, we were having a risk assessment, and I raised the issue that what if a lorry comes in and the batteries are already on fire within the lorry? And my colleagues sort of dismissed the idea. And then a few days later, that's exactly what happened. We had a lorry that came in, it had batteries on it. As soon as we took the pallet off the lorry, the smoke started. And so luckily it wasn't a very huge incident. We managed to put it out quite quickly, but that can happen. So sometimes the batteries are already on fire before they're taken off the transport lorry. Now the batteries that you want to look out for are lithium metal batteries. So these are those they can be Duracell batteries. You've now got lithium metal AA batteries. They can be these coin cells that go into watches and things. You want to look out for lithium thionyl chloride. Now these are extremely toxic batteries and they're very, very reactive batteries. So if if you were to damage these batteries, firstly they contain lithium thionyl chloride, which they contain thionyl chloride, which is actually similar to a chemical weapon. It's banned under the Chemical Weapons Convention, but they're extremely toxic and extremely reactive. But we get a lot of them because they're very expensive to get rid of. So people just chuck them into a lithium-ion battery, chuck them in with lithium-ion batteries. So you have to sort them out. Then you get nickel-cadmium batteries or NiCad batteries. They contain cadmium, which is of course very toxic. You've also got lithium sulfur batteries that you have to be careful of. You've got lead acid batteries, and of course you can have non-battery waste as well. So you can have all sorts of things in there. So to give an example of unexpected waste, you have to firstly train your operators to be able to recognize unexpected waste. So you can see here, we had a fire. So this is the first day that I started in this job. I started on January the 2nd. And the first day that I started, somebody said, "Oh, look, fire." We looked at the window and suddenly, the yard was on fire. And it was because a company had sent us lithium metal. So metallic lithium. It wasn't a battery. It was metallic lithium from a manufacturing process. and they'd labeled it as lithium-ion batteries, and they sent it to us. And of course, lithium reacts with water, and in the UK, it does rain quite a bit. So the water went into the barrels, produced hydrogen. The hydrogen ignited the lithium metal, and it was very, very difficult to then put out. So you have to have management procedures in place for unexpected waste, and you need to train them out. So you need to train your operatives as to what to do. Now, in this case, the operatives did the right thing. They recognized that it wasn't lithium-ion batteries, and they put it in a quarantine area. Now, even when it did catch fire, it didn't matter so much because it was in a safe area, and so we just let it. We controlled the incident. You have to have an up-to-date inventory on site, so you have to know exactly where everything is and what it is. So in this case, for example, when it happened, the fire brigade came, and when the fire brigade came, they wanted to extinguish it with water. And of course, if you've got lithium metal, the last thing you want to do is use water. So we quickly went up to them and said, no, this is lithium metal. You don't want to put water on there. And so we put vermiculite on there, and the vermiculite worked, and it managed to bring the fire under control. You want to segregate the batteries based on chemistry. So if you have, for example, nickel cadmium batteries, and you shred them alongside lithium ion batteries, then the black mass that you get will have cadmium in there. And cadmium is obviously it's a metal that the hydrometallurgical refiners do not want. It's very difficult to remove from the rest of the metals. It's hard to separate, and so you want to take out the batteries that you don't want to process with lithium ion batteries. Now, some of the batteries, they require, so non-lithium ion batteries, they require chemical neutralization after the shredding. So earlier on I mentioned thionyl chloride batteries or lithium thionyl chloride batteries. When you shred them, you make them a lot more dangerous, because what you're doing is you're exposing that thionyl chloride chemical to the atmosphere. Lithium-ion battery recycling plants are physical processes, they're mechanical processes, they're not chemical processes. And so if you do have a thionyl chloride battery in there, then what it does is it makes your black mass a lot more dangerous to human health, because it's now got a chemical in there that is extremely toxic. So let's say you've now sorted your batteries, you then have to store them. And storage is, again, a very dangerous activity. So batteries are at their most dangerous when they're either in storage or when they're being moved about during conveyance. So again, we had another fire. This was last year. And what happened was, we had containers like this. Batteries were in storage. Somebody came 10 minutes before the fire. They put a thermal imaging gun to, they analyzed the temperature of the barrels using a thermal imaging gun, and it was fine. The gun didn't pick up any reading at all. And then 10 minutes later, suddenly, poof, the whole bay was on fire. And so, you need to have the correct setup in order to essentially stop the fire from spreading. One thing that you will realize with lithium-ion battery recycling is that it's very hard to stop a fire from occurring. But once it does occur, then you need to have systems in place to store it. So the batteries must first be stored in certified containers. Now, I'll talk about those in the next slide. You need to have monitoring in place. So in this case, we've got a thermal imaging camera that watches the bay. And when it picks up a fire, then it sets off the sprinkler system, and then that puts the fire out. You also need, we've also got these blocks all around the bays. These blocks stop fire propagation. They're really good. And again, there's other ways to store batteries, so you don't have to store them this way. Another way could be to store them underwater, and that will then get rid of that fire hazard. It'll also discharge the batteries as well. So if you have a bit of a salt in there, you could discharge the batteries and reduce the fire hazard at the same time. This is something that we're looking into, but we haven't implemented it yet. Okay, so the storage containers that you want to store them in, they all have their advantages and disadvantages. So for example, you've got these metal containers that, so this is what the lithium metal came in. So you've got these metal containers. Now, they're more robust than these plastic containers. But the problem with these metal containers is if there's a fire inside there, then there's a huge buildup of pressure. and that in itself can then make the metal container very dangerous, because if it explodes, then you've got shrapnel going all over the place. You've got these wooden containers that people car manufacturers are still using. And this is probably the worst form of storage because it's a highly combustible material. But the car manufacturers have been using this for decades, and so they're continuing to use them. Each container has its own advantage, disadvantage, like I said. So we tend to store most of our batteries are stored in these containers as they come. But the batteries that we think that are quite dangerous, we store them in our own live boxes. Obviously, these are ADR 911 compliant, so you can store up to 20 kilowatt hours worth of batteries in there. And even if they were to go, the box can contain them quite safely. So post-storage, you've then got shredding. The shredding of the batteries is carried out in an inert atmosphere, generally nitrogen, which is what we use. When the shredder operation, when the oxygen inside the system falls below 1%, that's when the shredding begins. So the shredder is programmed to not shred until the oxygen is below 1%. Now the shredding, of course, generates heat by itself because it's a friction-based process. But also, as you'll find out in the next slide, there's a lot of internal short circuits that occur within the batteries, and that produces more heat. And so you're generating quite a lot of gases, and some of it is very flammable, and some of it is quite toxic as well. Now, it also produces acidic vapors and gases as well. So you can have hydrogen fluoride, you can have hydrogen chloride if there's any PVC present. And they attack the metal parts of the shredder, and that in itself can be dangerous as time goes on. Now, once the material is shredded and you have to convey it to the dryer, that's when the temperature of the material is actually at its highest. So you can see here, this work that was published, that the temperature rise, just for a 10% state of charge can be 60 degrees Celsius. We've actually measured temperatures in excess of 200 degrees Celsius post-shredding. So because we're shredding mainly portable cells, you can't really discharge them. It's quite difficult unless you put them in a saltwater solution or something. It's hard to discharge portable cells, and so therefore you have to shred them whilst they contain charge. And that chemical energy has to go somewhere once you charge them. Once you shred them, and generally it leads to an increase in temperature. Now you can see that the cathode material or the battery itself contains more than 10% oxygen by mass. And once it goes above 200 degrees Celsius, this oxygen begins to become available for chemical reactions. And, so you can get an even higher temperature than that. So you start to get pyrolysis reactions occurring. Now, pyrolysis of the electrolyte, you're producing HF and other gases. But it gets worse if you have things like e-bike batteries or power tool batteries where you have PVC present, because then you start to pyrolyze PVC and you start to get things like benzene. You start to get things like vinyl chloride and hydrogen chloride, and so it becomes really, really toxic really quickly. Now you can have smoldering fires, as I mentioned. You've got a lot of oxygen in there. So you can generate flammable and explosive atmospheres just from that pyrolysis process. Now the pyrolysis in the conveyance equipment, so the conveyance equipment can be an auger, or it can be a conveyor, just a normal rubber conveyor, and that conveyor can easily catch fire. That rubber can catch fire if the temperature is high enough. So then post-shredding, conveying, you've then got the drying. Now the drying step, most people, what they use is they use a vacuum to dry out or to evaporate out the solvents. Now there's normally two types of solvents in a lithium-ion battery. There's a linear organic solvent, for example, ethyl methyl carbonate, and that has a low boiling point. And then there's a cyclic organic solvent, so like propylene carbonate, and that has a high boiling point. Generally, the low boiling point solvent is evaporated off. If you get the temperatures are too high, for example, if they go above 100 degrees Celsius, then you start to break down the LiPF6 electrolyte, which then generates a lot of high HF, which then destroys your dryer. So the idea is to keep below a certain temperature. Now there's three approaches to drying. So there's a low temperature drying where a high vacuum is used. There's a high temperature drying, or so I say medium temperature drying, where a medium vacuum is used. So let's say you have temperatures of 200 degrees Celsius and a vacuum that's not that strong. And then finally, you've got pyrolysis, where the shredded material is heated to between 300 to 600 degrees Celsius to destroy all the electrolyte. Now, in the first one, you're only evaporating the low boiling point one. In the second one, mainly the low boiling point one, but some high boiling point one. And in this one, you're destroying everything. Now you can see that there's different types of electrolytes that are found within lithium-ion batteries. The most common ones, they have a boiling point of around 107 degrees Celsius. And these can be boiled off at a lower temperature, providing that it's a high vacuum. So why is the drying quite a dangerous step? Well, firstly, because you're generating flammable and explosive vapors. And secondly, when you generate them, you then condense them and you store the flammable liquids and explosive vapors. You're also generating toxic and corrosive gases. So for example, you can have HF, you can have POF3. And if you imagine you've got your dryer here, you've got a chamber that's under a vacuum and you're generating these flammable gases. And if you and you're also generating corrosive gases. So those corrosive gases can easily corrode the structure of the chamber, the metallic structure of the chamber, and you can generate like a little hole, a pinhole. So if you've now got a vacuum in this dryer and you've got a hole in there, then what happens is the oxygen goes into the system. And so if you obviously inject oxygen into a system or air into a system where you've got flammable vapors, then you can easily generate an explosive atmosphere within the dryer. So the dryer has to be under, and it has to have a lot of sensors in there, temperature sensors, oxygen sensors, etc., in order for it to operate properly. So once you do the drying, then the material becomes dry, and dried battery material, so dried black mass is extremely dusty. And so when you start to separate that black mass from other components, so you're using vibrations and things like that, you're throwing that material into the air. And so unless you have a very contained process, you're going to have a lot of dust that's generated. And so what you need actually is a very high grade of containment. And the requirements for this are becoming more and more stringent. So recently there was an EU report that was published, some recommendations, and they were recommending some really, really, really low tolerances for nickel and cobalt dust. And so the containment has to get even better. And now, of course, a way to avoid this is to have a wet process. But today I'm only going to be talking about a dry process because that's what we operate at Lightbat Recycling. Now, yes, this presentation is on dust explosion, so I thought I'd talk a bit about that. Now, black mass dust itself is not explosive, or at least it's not very explosive. But the black mass dust can contain material that can make it explosive. So let's just give a scenario. Let's say you're shredding charged batteries. Now, charged batteries, you know that lithium is at the anode, so it's on the graphite, and you have an element, or you have a chemical called LiC6, which is the lithium graphite. Now, and this is what the structure looks like. The lithium itself is elemental lithium, and so it's very reactive. So let's say a scenario, you've got a hot, humid day, like say 30 degrees Celsius. The EMC, so the ethyl methyl carbonate, it vaporizes readily. It's vaporizing. You've got a contained environment. Black mass dust is generated. It's exposed to air, and because it's a humid day, you've got water in the air. And water loves to react with lithium, and so as the water reacts with lithium, you're generating hydrogen, which ignites. And because you've got the electrolyte solvent all around it in the air, you can easily generate, a sort of an explosion. And so these are things that you have to take into account. So it's not the dust itself that may explode, but it's the electrolyte solvent that's on the dust. If it's given the right conditions, it can vaporize, generate a flammable atmosphere, and that can explode. And then the secondary explosion from that could be the dust itself, because it can still explode. It does contain graphite. Okay, so other than explosion hazards, there's also a number of other hazards that are associated with the dust. So as you can see here, there's quite a number of components that go into black mass. So you've got LCO, lithium cobalt oxide. That's a very common chemistry that you'll find in black mass. It's suspected of being cancer causing, and of course, it can damage unborn children as well. And then all the other ones, or most of the other ones, are also cancer causing. So anything with nickel and cobalt in there, or nickel and cobalt oxide, is classified as a potentially carcinogenic material. And you've got the workplace exposure limits. So again, these are for the UK. So for the LCO, for the cobalt and nickel containing material, you're talking 0.1 milligrams per meter cubed, extremely low. And actually, the recommendations from the EU is that it needs to be far, far lower than this. So yeah. So of course you need to contain the dust. You need to make sure that the people working in the environment are not exposed to the dust, and you also need to test the people. So every so often you have to test, you have to do like a urine sample testing to make sure that the nickel and cobalt are not getting into their system. And then of course there's other hazards, or slightly smaller hazards than what we've been talking about. So the black mass, for example, it contains graphite, and graphite is a lubricant. So if you've got graphite dust on your floor, for example, it becomes extremely slippery. It's like walking on ice sometimes if there's graphite dust somewhere. It's also conductive. So if you've got any electrical motors and things which you will have on your shredders, you need to make sure that they're ATEX rated. They need to be ATEX rated because, of course, you've got the the explosive atmospheres or flammable atmospheres generated from the electrolyte, but also the dust itself can short out these electrical motors. Now, if you want to try this, get a vacuum cleaner and suck up some black mass, and it will just kill it. It will short it out. So yeah, it destroys electronic equipment if dust enters the circuitry. Now, one other thing to be aware of, let's say you have a discharging and dismantling operation nearby. If you've got a dusty environment, the dust can migrate and fall on these batteries, and it can actually short circuit these batteries, leading to a fire. So that's another thing to be aware of. Finally, you've got the black mass storage. Now, black mass storage can also present a number of hazards as well. So black mass contains LiPF6, it contains flammable solvents, and it also contains aluminium and copper foils. So the LiPF6 in the black mass is hygroscopic. So what this means is that it absorbs the moisture from the air. So if you leave black mass just anywhere, it absorbs moisture, it becomes wet. And so when it does, it generates hydrogen, lithium fluoride, and HF. Sorry, not hydrogen. It generates HF and this POF3, which in itself is a very corrosive gas. So the HF can react with the aluminium, which it will, and it'll generate heat and hydrogen. And again, that can generate a fire in and of itself. You can also have the water reacting with the aluminium foil, and that again then generates heat and hydrogen. And aluminium foil is actually a very dangerous component. And yeah, that is my presentation. Thank you very much. I look forward to your questions.